that root over of 1 plus cos a by 1 minus cos a, right? I think this question is visible to you. We need to find the value of this. Okay, the question is in front of you. So here, to solve such question, students, do you think how to proceed? Whenever you are seeing such questions, you are not able to judge. If you are not able to judge immediately, then you just apply the previous learnings over here. Okay, why I am saying this? Because suppose root over 1 plus cos a by 1 minus cos a is there, right? Then we are now, it's not given that what is the value of a, what is the value of whatever the value will be coming for 1 minus cos a or 1 plus cos a. You can simply just move forward with the steps which you are knowing. So into such questions where radical is there, you know that, and the root is there over the denominator also, then you can simply rationalize it. Okay, so it's 1 minus cos a into the denominator, you can simply rationalize it. That means the denominator is 1 minus cos a, right? Then it will be multiplied with 1 plus cos a, root over of 1 plus cos a into the denominator, right? 1 plus cos a. Let me squeeze a little. Yeah, I think it's visible to you. Yes, its root over 1 plus cos a will be multiplied into the denominator, and since this is inserted, this will be compensated with a multiplication of root over of 1 plus cos a into the numerator also, right? What is the benefit of this? You will be seeing it. We are knowing that since all this is into root and all are multiplied, right? Then we can write it as, take a bigger root, right? And inside that root you can write 1 plus cos a, this one, and the second one into the numerator, that is 1 plus cos a. Can it be written like this or not? Tell me. Since both of these are multiplied, then and root over the first term and root over the second term also, so we can do it, right? Similarly, 1 minus cos a and 1 plus cos a will be coming to the denominator. So let me write it. Right, you know the formula, just recall it, how to move forward. So into this case, you can see 1 plus cos a, this one is coming two times, right? So we can write 1 plus cos a whole square into the numerator, and whole of this is be divided by, will be divided by 1 minus cos a and 1 plus cos a. You know the formula a minus b and a plus b, so definitely it will be converted into that, and the resultant will be a square minus b square. So the denominator can be written as, in place of a, it's 1 square, in place of b, it's b square, so it will be cos square a, right? So this will be 1 minus cos a, and 1 plus cos a will be converting to 1 minus cos square a, right? Now into the next step, you can see 1 plus cos a is coming two times, and this is under the root, under the root. So we can say, we can just bring 1 plus cos a outside of this root, because there are two terms into the numerator, right? So one term can be taken out. Similarly, it's 1 minus cos square a. 1 minus cos square a is, let me remove the root into the next step so that it will be easier. 1 minus cos square a can be written as sin square a. Why it can be written? I am just writing you the formula. You know that sin square a plus cos square a is equal to 1, right? Since we are knowing this, then instead of 1 minus cos a square a, so we can write from this formula sin a square a as 1 minus cos a square a. So we use this identity over here. That's why we, in place of 1 minus cos a square a, we have written sin a square a, right? Using this one, right? Now, into the next step, what will happen? Into the next step, 1 plus cos a whole square is there inside the root. So we can bring 1 plus cos a outside of this root, right? And into the denominator, it will be sin a square a. And a square root of sin a square a will be sin a, right? So this can be further written as 1 by sin a. Divide it individually. It can be further written as 1 by sin a plus cos a by sin a, right? And 1 by sin a is nothing but cosec a, and cos a by sin a is nothing but cot a. So this is your answer, your students. The above radical just simplifies to cosec a plus cot a. So cosec a plus cot a is the value of root over 1 plus cos a by root over 1 minus cos a, right? So students, in this way we have solved this question. Let me take the second question for today's series. The second question which we are going to take today. It's given that if sine alpha, yeah, the question is that sine of alpha plus beta is equal to 1. This is given to you. Sine of alpha plus beta is equal to 1. And sine alpha minus beta is equal to 1 by 2. This is given. All this is given, right? In this case, we need to find tan of 2 alpha plus beta multiplied with tan of alpha plus 2 beta. What is the value of this? If this is given, sin alpha plus beta equal to 1, sin alpha minus beta equal to 1 by 2. So students, into such cases, you need to remember few of the values for all the trigonometrical ratios. Basically, for sine, cos and tan. Then accordingly, you can derive for all others. Just remember few of the values for sine, for cos and for tan. What are the values which you need to remember? The values for 0 degree, 30 degree, 45, 60 and 90. If you are knowing the value of all the corresponding sine, cos, tan values, right, then you will be easily able to calculate any of the higher values, okay, or even all the ratio of values of all the trigonometrical ratios. Reverse of sine is cosec, reverse of cos is sec, reverse of tan is cot. All those values could be easily calculated. So just remember it, right? Suppose you are going to find the value of sine of 930 degree. You'll be able to calculate. Sine of 1860 degree, you'll be able to calculate. Yeah, I have already explained it how to find it, but yes, I will explain it later on into the next session. So just remember, just coming back to the topic. Sine of 0 degree. Sine of 0 degree is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Sine 60 is root 3 by 2. Sine 90 is 1. So just remember this. Okay. So from this you can take the, just remember that sine of alpha plus beta is 1. Sine of alpha plus beta is 1. Then just recall into this trigonometric table where it is 1. 1 is here at 1 is here and it is at 90 degree, right? So can we write it, this one, as equal to sine of 90 degree? Can we write it? Tell me, students. If you write it at this is as equal to 90 degree, then from comparison you can say this alpha plus beta is equal to 90, isn't it? Then from here we can write alpha plus beta is equal to 90 degree, right? Similarly here alpha minus beta is 1 by 2. Sine of alpha minus beta is 1 by 2. So when we are getting the value of 1 by 2, you can see sine of 30 degree. Sine 30. Sine of 30 is 1 by 2, right? So here instead of 1 by 2, we can write this is happening for 30 degree. So we can write alpha minus beta. From here we can say alpha minus beta is equal to 30 degree. Why? Because sine alpha minus beta is 1 by 2. So we will be having two equations with us. You can see alpha plus beta and alpha minus beta, right? So if alpha plus beta is 90 and alpha minus beta is 30, right? Then from here if you add the equations, one of the variable will be cancelled out, beta will be cancelled out, and we have the value 2 times alpha is equal to 90 plus 30, that is 120 degree, right? And this will give you the value of alpha as 120 by 2, right, which is coming as 60 degree. So 60 degree is the value of alpha. 60 degree is the value of alpha which is calculated, right? Similarly, when you just subtract both of these equations, then you will get alpha plus beta equal to 90 and alpha minus beta is equal to 30. When you subtract it, this plus sign converted into minus, this minus converted into plus, and this plus converted into minus. And here you can see alpha and alpha will be cancelled and we'll get the value of 2 times beta. 2 beta is nothing but 60 degree. 90 minus 30 is 60, right? So this will give you the value, this will give you the beta value of beta as equal to 60 by 2, which is coming as 30 degree. So the value of beta is calculated as 30 degree, right? So now you are knowing the value of alpha. Alpha is 60 and beta is 30, right? Here we have calculated alpha and here we have calculated beta, right? Now we are going to find the value of tan 2 alpha plus beta multiplied with tan alpha plus 2 beta, right? Then we can write tan of 2 alpha plus beta multiplied with tan of alpha plus 2 beta. This one alpha plus 2 beta. This we are going to calculate. This is equal to how much, right? So here tan of 2 alpha plus beta will be nothing but tan of 2 times alpha. Alpha is 60. So it will be 2 times 60 degree plus beta. Beta is 30. Just simple arithmetic calculation, nothing else. right, multiplied with tan of alpha plus 2 beta. What is alpha? Alpha is nothing but 60, and 2 beta, that is 2 multiplied with, what is beta? Beta is 30. 2 multiplied with 30 degree, right? So this will be coming as tan of 60 into 20 is 160 into 2 is 120. So 120 plus this 30, tan 120 plus 30, that will be coming as tan 150 multiplied with tan 60 plus 60, right? So this will be giving you tan 150 degree multiplied with tan 120 degree. So students, what is the value of tan 150 degree? Tan 150 degree can be written as, just break into multiples of pi by 2 or multiples of 90 plus theta. In this way we are going to solve, because just you need to remember these values only, right? So tan 150 can be written as tan 90 degree plus, tell me, 60, right? And tan 120 degree can be written as tan of 90 plus 30 degree. So into this case, if tan 90 plus 60 and 90 plus 30, you can see the prefix of 90 is odd, then this tan will be converted into cot. How? The how much 90 degrees are there? Since the 90 degree is the, we are having odd multiple of 90 degree. So in this case, tan will be converting into cot. Tan will be converting into cot, because the prefix of this 90 degree is nothing but a odd number, 1. 90 can be written as 1 into 90. So due to this one, this tan is converted into cot, right? Why? Because odd multiple of 90 degree, which is here 90 degree is coming 1 times and 1 is a odd, that's why this tan converted into cot. So this will be equal to cot of 60 degree, the first one, multiplied with, similarly over here this tan will also be converted into cot, and the value will be 60 plus 15, 30 degree, right? 30 degree. So cot 60 and cot 30, if you are knowing the value of this, your question is solved. What is the value of cot 60? Cot 60, if you are knowing the value of tan 60, then it will be easier to calculate the value of cot 60. Since tan of 60 degree is root 3, tan of 60 degree is root 3, then cot of 60 degree is nothing but reverse of that, that is 1 by root 3. And if tan of 30 degree is 1 by root 3, then cot of 30 degree is reverse of this, that is coming as root 3. And we need to also remember the sign. If you follow the sign convention, then into the first quadrant all trigonometrical ratios will be positive, right? Into the second quadrant only sine will be positive. Into the third quadrant, only tan and its reverse. I'm saying sine, that means sine and cosec both will be positive into the second quadrant. If I'm saying tan is positive into the third quadrant, that means tan is not only not only tan, instead the reverse of that, that is cot is also positive into the third quadrant, and into the fourth quadrant cos, and reverse of this, that is cosec, right? Now here we can see cot 60 multiplied with cot 30. Therefore cot 60 degree multiplied with cot 30 degree is equal to, what is the value of cot 60? Cot 60 was 1 by root 3, right? Cot 60 is 1 by root 3, and this is lying into the first quadrant, right? 60 degree is lying into the first quadrant. Even 30 degree is also lying into the first quadrant, right? You can see into the first quadrant we are covering till 90 degree, right? And it's only 60. So this is lying into the first quadrant, so the sign will be positive, plus 1 by root 3. Similarly, cot 30, cot 30 we have calculated root 3. So it will be root 3, and the sign of root 3 will be, since 30 is also less than 90 and lying into the first quadrant, the sign will be positive. So 1 by root 3 multiplied with root 3. Here you can see this root 3 and this root 3 will be cancelled out. And we are having the value as equal to 1. And this is our answer. 1 is the value which is calculated for our question, that is tan of 2 alpha plus beta multiplied by tan of alpha plus 2 beta is equal to what? Yes, this what will not be there because we already calculated, and this value is equal to 1, right? And in this way we have solved this question. Hi Dev. No, this is not from straight lines. This is not from straight lines. This is basically from trigonometrical ratios and trigonometrical identities. Okay, straight lines will be it's a separate chapter, right? So it's basically from trigo, right, my dear friend Dev? So in this way, into the two question series, we have solved this question for today. This was the second question. Let me write, go through the recordings. You can see, for any query, just put up into the comment box, right? This is the entire solution in front of you. Let me show what is happening backstage. In this way, I'm using this notebook to solve it. Okay, I'm just using half of the page, so that whenever you are able to show you to your students, you can zoom it like this, right? And further you can squeeze. So at the last, as usual, I am showing that how I have solved it. This is the arrangement. This is a notebook where I am doing it. Okay, and the first question you can see here. So if I will rotate it, you can see the first question which we have discussed for today. This was the first question. So that's why in the half portion of this notebook I am solving the first question, and this was question number 1. And in this way we have proved that root over 1 plus cos a by 1 minus cos a is cosec a plus cot a, which is solved. And question number 2, I am just rotating the notebook and using the rest of the half portion of the page to solve it, right? And this is calculated as 1. So 1 is calculated as the value of tan 2 alpha plus beta multiplied by tan alpha plus 2 beta, or tan alpha plus 2 beta multiplied by tan 2 alpha plus beta, or vice versa. This value is calculated as 1. So thank you so much for watching, students. Take care. Happy learning. Bye bye. See you again into the next session. Bye bye. Bye my dear friend Dev. See you. Bye my dear all friends. Bye bye.